Lesson: AI integration into organizational security architectures. AI integration into organizational security architectures presents a transformative approach to safeguarding digital assets and enhancing cybersecurity measures. By utilizing AI technologies, organizations can anticipate, identify, and mitigate cyber threats with unprecedented accuracy and speed. This lesson focuses on actionable insights, practical tools, frameworks, and step-by-step applications that professionals can directly implement to bolster their cybersecurity strategies. The integration of AI not only augments existing security protocols, but also paves the way for a proactive, rather than reactive stance in cybersecurity. One of the core benefits of integrating AI into organizational security is its ability to process vast amounts of data in real time, identifying patterns and anomalies that could indicate a security breach. Machine learning algorithms, a subset of AI, can be trained to recognize these anomalies, even those that deviate only slightly from the norm, which might be missed by human analysts. For instance, AI-driven tools like Darktrace utilize machine learning to detect threats autonomously, adapting to new threats as they evolve. This adaptive learning is crucial in a landscape where cyber threats are continuously morphing. Moreover, AI can enhance the capabilities of security information and event management systems. Traditional SIEM systems aggregate and analyze security data, but they often generate an overwhelming number of alerts, many of which are false positives. AI integration can refine this process by correlating events across multiple data sources, reducing noise, and identifying genuine threats. IBM's QRadar, for example, incorporates AI to prioritize alerts and provide actionable intelligence, thus enabling security teams to focus on high-risk threats. This prioritization is instrumental in optimizing the efficiency of cybersecurity operations. Another significant application of AI in security architecture is in the domain of endpoint protection. AI-driven endpoint security solutions, such as those offered by Cylance, employ predictive analysis to prevent malware attacks before they occur. By analyzing the DNA of files and determining their potential threat level, these tools can block malicious activities preemptively, reducing the reliance on signature-based detection methods, which are often one step behind emerging threats. AI also plays a pivotal role in enhancing identity and access management systems. By employing AI algorithms, IAM solutions can continuously monitor user behavior, establishing baselines of normal activity and flagging deviations that may indicate compromised credentials. This continuous authentication process is becoming increasingly important as organizations move towards zero-trust security models, which assume that threats can originate both outside and inside the network. Okta, a leading provider of IAM solutions, uses AI to perform risk-based authentication, improving security without impeding user experience. Incorporating AI into organizational security architectures also necessitates a strategic framework to guide its implementation. The National Institute of Standards and Technology cybersecurity framework provides a robust foundation for integrating AI technologies. This framework outlines 5 key functions: identify, protect, detect, respond, and recover. AI can significantly enhance each of these functions by providing tools that automate identification and detection processes, strengthen protective measures, facilitate rapid response, and expedite recovery efforts. For example, AI-driven threat intelligence platforms can automate the collection and analysis of threat data, identifying potential risks in real time and enabling swift responses to mitigate them. Despite the clear advantages of AI integration, organizations must also address potential challenges and ethical considerations. One such challenge is ensuring the transparency and explainability of AI systems. As AI algorithms become more complex, understanding their decision-making processes becomes more difficult, which can lead to a lack of trust among users. It is crucial for organizations to implement AI systems that provide clear explanations for their actions, thus fostering trust and accountability. The European Union's General Data Protection Regulation emphasizes the importance of transparency in AI, stating that individuals have the right to receive explanations for automated decisions that significantly affect them. Furthermore, AI systems must be protected from adversarial attacks, where malicious actors attempt to deceive AI models by manipulating input data. Ensuring the robustness of AI models against such attacks is essential to maintaining the integrity of security systems. Techniques such as adversarial training, where AI models are exposed to manipulated data during the training phase, can enhance the resilience of AI systems against these threats. To illustrate the real-world impact of AI integration in organizational security architectures, consider the case study of a financial institution that implemented AI-driven fraud detection systems. By leveraging machine learning algorithms, the institution was able to reduce false positives by 50% and detect fraudulent transactions 30% faster than traditional methods. This not only improved the efficiency of their security operations, but also enhanced customer trust by minimizing disruptions caused by false alerts. In conclusion, integrating AI into organizational security architectures offers a formidable advantage in the fight against cyber threats. By automating and augmenting critical security functions, AI enables organizations to anticipate and respond to threats with greater precision and efficiency. However, successful implementation requires careful consideration of ethical issues, transparency, and the resilience of AI systems against adversarial attacks. By adhering to established cybersecurity frameworks and leveraging cutting-edge AI technologies, organizations can create a robust security architecture that not only protects their digital assets, but also adapts to the ever-evolving threat landscape.